మహేష్ చెప్పు. చూస్తున్నాను మహేష్. నాకు కాదు, అదే జిఎల్డబ్ల్యూసీకి వస్తుంది. మహేష్ నేను చూసి మళ్ళీ పంపిస్తాను నీకు. వాట్సాప్ చేసి. కాసిం,
Sir,
అదే ఐ మేక్ యూ లైక్ మేడ్ యూ కో హోస్ట్ అట్ 2 logins, అండ్ హిమబిందు మ్యామ్ వాజ్ మేడ్ హోస్ట్. ఓకే.
okay, sir. Okay.
అండ్ దిస్ మీటింగ్ ఈస్ బీయింగ్ లైవ్ స్ట్రీమ్డ్. బీ కేర్ఫుల్.
Yes, sir. Yes. Thank you, sir. Thank you.
మ్యామ్, ఆర్ యూ దేర్?
Yes, sir, I'm there. I'm sorry, I didn't know the capacity was 100. Otherwise, I wouldn't have.
No issue, no issue. No problem. Now it's being live streamed onto YouTube link. Anyone can watch. Don't worry.
Right, right. Sir, are we post? Do we need to post that link somewhere or?
No, I posted in GRIT faculty group already. If you want, you can post it some other places also.
Right, sir. Thank you very
As
much.
your wish.
Yeah.
Kasim, please check YouTube link whether it's working or not.
Working, sir. I have seen.
Sir Kasim sir, how many participants have registered for today? Do we have the count of the participants who are registered for today?
Madam, 37.
Right, sir. I just hope all the 37 join without fail along with other faculty. So if any of you have attended the sessions yesterday and the day before, kindly you can exit after the first two sessions. I just wanted all of you to get a grasp of Principal Sir's address and JNM Sir's essence of PBL. That is the sole idea of requesting all of you to join today's session. If you have attended my session yesterday and the day before, you can exit after the first two sessions. I'm repeating myself again. Thank you very much.
26 joined, madam.
Yes, sir. We'll start on time according to our schedule. Just a couple of minutes here and there. I see Praveen sir has already joined, so there shouldn't be much of a delay for us to start. We'll just wait for JNM sir also to join, sir. Kasim sir, shall we?
Yes, madam, we can start.
10:30, yeah.
Good morning. Good morning, everyone. I'm KNV Kasim, Assistant Professor, Department of ECE, and coordinator of this workshop. It's a pleasure to welcome you all to the online faculty development program on experiential learning organized by GFTDC in collaboration with the Department of ECE GRAT. This 3-day FDP focuses on problem-based and project-based learning in alignment with NEP 2020. We are honored by the presence of Dr. Janjal N. Murthy, Director, GRIT, and today's one of the resource person, Dr. Praveen Juge, Principal, GRIT, Dr. C.H. Usha Kumari, Convener, Professor and HOD ECE, Dr. Himabindu, Professor, Dean, FTP, another resource person. I also warmly welcome all faculty participants. Your participation highlights a collective dedication to enriching teaching practices through innovation and student-centric approaches. Over the past 2 days, the sessions have been interactive and the issues raised were addressed effectively thanks to the presence of experienced and knowledgeable mentors. Let's work together, share ideas, and make this workshop a meaningful experience for all. Once again, welcome all. It gives me immense pleasure to welcome our esteemed principal, sir, whose unwavering motivation towards teaching and learning continues to inspire us all at GRIT. Sir, may I now humbly invite you to deliver the presidential address for this workshop?
So, good morning, sir. Are you able to hear my voice?
Yes, sir.
Okay. So, thank you for giving me this opportunity to talk. So, first of all, I want to congratulate Department of ECE and also Dr. Himabindu Garu for taking this initiative to have this workshop on experiential learning, also on project-based learning or problem-based learning. So though most of faculty are in summer vacation, but still taking up this initiative to conduct workshop to improve the teaching learning practices among the faculty. So for that, I want to congratulate all of you. So those who are conducting and also those who have joined. So as you know that the conventional teaching learning methodology, as per the requirement of the statutory bodies, we need to write exams. So students will mug up the answer and almost it is like a rote learning process. So they try to prepare some old question papers and they'll try to remember something and they'll try to almost like vomit in the examination hall. So after 4 years, if we ask something, most of the time they say, sir, we studied in first year, second year, right now we don't know. So that type of attitude may not work in industry actually. Industry, they require everyday new skill actually. So looking in this direction, so basically we require discovery, exploration, practice and action. So we require adaptive and experiential learning. Adaptive means things are not linear actually. So we have to deal with complex problem. Then we have to make hands-on project and internship. Though this hands-on project and internships are already embedded in our curriculum, so we need to give more focus on it. For example, some students may take up online internships and they may not learn anything actually. So we need to insist students to actually go to some industry, find, try to work there for 15 days or 3 weeks or 4 weeks and try to learn few things actually doing hands-on. Similarly, we encourage our students as well as faculty members to participate in hackathons, solving real world problems, take up challenges, building software applications, etc. For example, in AAC and we have remote internships, so where we have industry mentors also, and also we conduct multiple guest lectures from industry so that we will know what is actually happening in the industry. So when we are doing projects, also we receive feedback from the industry and from the users actually. So need to practice innovative strategies, have practical skills, in-depth knowledge. So this is the aim of this PBL. So we should have proactive learners, and we should have problem solving approach actually. So already we have included design thinking in first year. So that mindset we require, innovative mindset. So need to understand deep tech. It's not like superficially we learn something and do project. It is not going to work. So we need to work about deep tech, deep then innovations, leadership. So here teacher's role is like he should lead students to actually do this project on their own and try to guide them wherever required. We need to also have business strategy. For example, if you want to take this product to industry, so we should know who is actually the user of this product, etc. So we should have transformative learning experience, cutting edge concepts, real world applications, collaborative work. So finally, a student should come up with a capstone project, should develop professional skills, and also in this process they should develop networking. Then the problems must be multidisciplinary or transdisciplinary. And now you can see sustainable development goals. So recently our India also, they developed the sustainable ranking also. So earlier it was out of 100, but now out of about 190 countries, India is now first time it is in inside 100 top 100 countries actually. So it is there in somewhere 90s. So every year we are able to improve the sustainable development goals. So as teachers, we should inculcate this SDGs in our projects and problem-based learning. We should think how we can make this planet sustainable. So we need to encourage students to learn about the sustainable practices. Recently, I attended some conference. So in that, people are saying that even the material what we are using for computers, laptops, or the mobile, etc. People are developing using the sustainable material. So already it is a recycled material. Similarly, we should also think if you are talking about material science. So how to make it sustainable material and what about the recycling, etc. So coming to PBL, so the main concept of PBL is active engaging, real world problems, collaboration. We should inculcate critical thinking, creativity, and we should ask students to solve a complex problem. We should take up open-ended problem in real situations. So require. So this is preparation for the future, and also think about community design. So think about what are the community challenges. Can we take up one challenge and can we solve this problem? Then we should have rubrics also. So we should give targets to the student that up to what level they should try to extend the PBL or projects, etc. The standards are like we need to align to the standards, build the culture, manage activities, then explore student learning, then assess. We need to assess also. So maybe weekly once we need to see what actually they are doing, engage and coach, design and plan. These are all the standards of the PBL. Coming to the design elements, so sustained inquiry. So always ask students, ask themselves that what are the different questions uh, with respect to their project. Then authenticity, student voice and choice. So here we give freedom to students. So student can come up with multiple solutions. Then he should take reflection from either teacher or from his peers or maybe from community. Critique and revision. So finally, he is making a product actually. So should able to solve the challenging problems. So these are all the few points with respect to PBL. So though I am just able to tell in just nutshell, hope the coming sessions will give more in-depth knowledge about PBL. So I wish you all the best for this session on PBL and experiential learning. And I want to thank the organizers for giving me this opportunity. Over to you, madam. Thank you.
Thank you, Principal Sir, for the uplifting speech. We now move on to the first session of the day. It's my honor to introduce our esteemed resource person of this workshop, Dr. Janjal N. Murthy. Dr. Murthy has been leading GRET as director since January 2018 after serving as principal from 2004 to 2018. A retired wing commander of the Indian Air Force, he also led a technical training mission to Botswana, showcasing his global experience. His academic interests include thermal engineering, gas turbine combustion chamber simulation, and engineering education, along with a strong inclination towards topics like emotional intelligence and holistic faculty development. Today, he will be speaking on the essence of experiential learning, sharing valuable perspectives drawn from his vast academic and leadership journey. We are privileged to have him with us. Sir, we now invite you to deliver your session.
Should we stop sharing and just have only the faces? Kasim sir? Yeah. So that there's nothing much to focus on slides as it stands. Shri Guru Bhyo Namaha. Namaskar. Good morning, everyone. I start on a slightly philosophical note. That is, all of us are responsible stakeholders in this teaching learning environment. We all understand the W's and the H, which actually haunts us throughout while teaching. What, how, when, where. The last one is how. Why I'm stressing on this how is, the question which haunts us is, I taught whether the student have learned or not. And the next question comes, do I have to teach? Next question is what to teach. This what to teach, absolutely there is no doubt in the area or the concepts that we are supposed to expose the student to. But the main part is how. That how is the one which differentiates between a good institution and a average institution or an institution to reckon with. So all of us have to focus on this how. If you take age-old system of teaching, that is thousands of years back, the Upanishads say the information is transferred from Guru to Sishya if they can follow these 3 or 4 ideals. Drashtavya, that means get a good teacher. Shrotavya, whatever he teaches, listen to it. Mananavya, you do sort of dhyan, in the sense you mull over it. And last one is nididhyasa, that is you meditate on that and you do a deep introspection on that. And thousands of years, all the Sishyas, the names which you know, not all of them are famous. The only names which we hear is the some rishis names and, Arjuna and, something like that. So the same way, our students or teach as gurus, all of us have been following this principle of we go on giving lectures, expecting the student to listen to it and do the mananam part of it, and subsequently nididhyasam, that is introspection and deep meditation on the subject. And to be honest with you, all of us are doing fantastic job as far as this first part of delivering the lecture is concerned. Now comes the question, because the generations are changing and the time span is reducing, so he is not listening to us completely. So how do we attract his attention? And subsequently, how do you make him actually get to mull over it? And the standard one is, if I say you forget. If I show you picture, that is the video, he may remember. But if I make him do it, certainly it will become an experience and it becomes a habit to him. And that is what we are actually, the meaning of education. Whatever we teach, there should be a transformation in such a way, it becomes a habit in the learner. So now it comes to, the simple example is this. I teach you about overspeeding, you may get into accident. These words will not, people forget it the moment they sit on the scooter. I may show a video showing variety of accidents. Even then, he may remember, but he may not sort of desist from going very fast. But if he gets into accident, that he'll definitely remember for the rest of his life. And more number of accidents, obviously he becomes such an expert that he'll not do accidents subsequently. It's a vague and wrong example, but you can see the importance of actually going through the activity in order to that become as a sort of a habit for you. So that's how all these terminologies have come from passive learning to active learning. So the moment you involve the student, that involvement, there are only 2-3 ways of doing it. He gets into discussion, he takes part in the whole sort of analysis along with the teacher, or he does an experiment, or he himself comes up with a solution, or he does a simulation by himself, or that nididhyasa, that is, he analyzes the whole thing and comes up with a solution, in which case it becomes part and parcel of his personality, and he becomes sort of aware of the concept much better than me teaching and he listening to it. So that's how the shift changed. Not today, it's been realized maybe about 30-40 years back. Western countries have reached that stage, but we are still following our sort of cultural traditional value of we speak, they listen. So now we come back and say, yes, we all realize that active learning. So in this active learning, one of the methodology is this experiential learning. That is, make the individual to go through that concept and experience it. So the amount of talk or giving inputs has to be bare minimum to an extent. Yesterday also somebody has pointed out, right now there are a lot of what you call drawbacks in this system for one simple reason. That is, the student is not prepared yet to be called as, to be deservingly called as Vidyarthi. He is not the one who is searching for the education. He is not the one who is actually seeking for it. We are actually forcing it on him. So the day the shift happens, he will actually run and prepare himself to accept the bare minimum instructions, and subsequently it is he who has to actually devise the plan. So in this experiential learning, whether you call it problem oriented PBL or project oriented learning, project based learning, the concept is very, very simple. You will now be exposed to some, two concepts called IoT, how they have done it, and in blockchain, how they have done it. Maybe the examples will make it very, very clear to you. So in the normal case, any concept I teach for the first, if suppose I have got a subject or a unit, if I am taking about 10 hours, 8 to 9 hours, I'll go on explaining all the rules and fundamentals with clear examples. And I struggle very hard that every student in that class of 60 actually follows the whole thing. So in the experiential learning, the problems you choose or the concepts which you'd like to choose, you only give the outline or give the real world problem. Just now, Principal Garu has told three items. I would like you to understand the correct meaning of that. I'll not spend time on that. One is complex problems, critical thinking, and real world problems. Please Google and find out exactly the meaning of all these three. Then you are sort of, you become more armed and strengthened in order to answer such questions. So now if you have to teach a concept, any concept of your course, or maybe the entire course, what is required is the objectives have to be made very clear to the student right in the beginning itself. Once the objectives are clear, I do not go on explaining the fundamentals, the history, how it is done, what are the tools involved, and give examples like Teraja, come up with all the worked out examples at the end, and then give an incrementally difficult one or a problem which has already been practiced. I test him in the examination. So you got to break away from that and say, after exposing the student to the the objectives of it, a real world problem or a problem with an open-ended type of solution, you sort of offer it to him in such a way that when you say open-ended problem, the solutions could be more than one. There's no unique solution for that. So it depends on the path the student chooses in order to come up with the solution. It will come, a minor variation will be there in the solution. So after explaining the objective and the problem, give them a hint, the procedure of how you do it. These two, our resource persons, our Asthana Vidwansalu actually, that is Himabindu Madam and Krishna Chaitanya, they're going to explain it to you. Okay. But I'm just giving you an overview of that. That is, once the objectives are known of what we have to learn and the real world problem, and leave that pathfinding to the student himself. But as a facilitator, you have to be there in order to guide him, because he is actually following the steps and he is searching the path by himself. That is, now no longer it is the push technology, it is the pull technology, that the student now has to find out what are the means by which we can reach the end stage. This known to unknown, he has to search the path and not you. But you will clearly give the paths that he has to choose, the guidelines or an overall idea. You would have given it right in the beginning itself. With this learner will try to solve the problem. In the process, his knowledge of that concepts or objectives that are being laid out for that learning sort of topic, he gains. Since he has learned it through an active means, the expectation is that he learns it in a much better way, which is going to remain for a longer time than what if you, I mean, not just for the exam sake alone, but it will be useful for the life itself. The only difference between a problem and a project is, problem is done for a short while and it will only allow him to understand the topics. He may come up with a solution, but you extend it a bit more and come up with a slightly more involved, deeper problem, in which case he comes up with a product or a proof of concept by the time he finishes that, which we term it as a project-based learning. So whether it's do not get worry about the semantics between the difference between a problem-based and the project-based, but the lectures, when you hear it, you will understand it very clearly. And we are already doing it knowingly or unknowingly. They'll explain all that. So what I would like as teachers, I would like you to experiment this active-based learning technique, either for a topic or for one simple problem or for the entire course. Entire course is slightly beyond our expectation at the moment because the students are not yet ready. In fact, even us as teachers, we are also not yet ready. Understand the concepts and see to what extent you can apply it in your course to at least one unit, one subtopic or one problem. Try to do it through this new methodology called experiential learning. So I first of all congratulate Himabindu and Krishna Chaitanya madam and the entire ECE department to come up with this. Let's hope the knowledge as far as this new technique or not new techniques, the approach, the paradigm shift that we are trying to bring into our GRIT system. All the best. Thank you very much.
Thank you, sir. That was a wonderful session and truly reflected your expertise on the topic. Now we move on to the second session of the day. It's my pleasure to welcome Dr. Himabindu Valiveti, Professor in ECE GRIT. She is an expert in AI-based signal processing and experiential learning with over 18 years of academic and industry experience. She has published widely, worked on funded projects, and actively promotes NEP-based outcome teaching. Today, her session will focus on problem-based and project-based learning. Welcome, Himabindu Madam, for learning from you. Over to you.
Am I audible and the screen visible, sir?
Yes, ma'am.
Yeah,
Both
thank
are
you.
okay.
Yeah, thank you. So I guess the essence of the entire session has been clearly told in a nutshell by our principal, sir, and emphasized on the PBL and the difference between PBL and project-based learning by sir. So what all of us intend to do towards the end of this session is we don't teach anymore, we make them do. It is learning by doing. That is the entire agenda. And we will be showcasing a couple of case studies that myself and Dr. Krishna Chaitanya have done over the last 1 year. And sir has been involved in PBL for over 2 years. So he's a much better expert in that. So I'll be sharing the knowledge that I've gained while working with these case studies. And I hope we all start teaching by doing. We no more teaching, we will be facilitating. That is the whole agenda. And I thank Principal Sir and Director Sir for insisting on putting up this FTP. Special thanks to Principal Sir. He was very keen on having this FTP during the summer session so that all of us can start implementing PBL for the upcoming semester. And likewise, JNM Sir has been behind the scenes. He's been pushing us, he's been correcting us, he's been learning more about experiential learning and encouraging us to put forward whatever knowledge we have and create awareness. I thank you too, sir. So starting with, as Sir said, I start with the Benjamin Franklin quote. I came across this while I was trying to do research. Tell me and I forget, teach me and I remember, involve me and I learn. At the end of the day, we always say learning outcomes. We don't say teaching outcomes. It is learning outcomes. So learning is the most important agenda, and learning is best done when a student is involved actively. So this PBL or experiential learning or project-based learning or the ICT activities that we have been doing for over a very long time are for the involvement of the student. That is what our basic agenda is. And experiential learning also endorses the same, but the way in which we pursue it, the way in which we facilitate it changes from the traditional learning or the ICT activities that are put in place. So this is going to be the entire outline of the presentation. What is experiential learning, and we will not deep dive, we will definitely deep dive, but with the help of case studies. We're not going to talk about theory, as there's no theory anymore. There's understanding and implementing, and the differences between what problem based and project based is for the same theme. And why do we need to integrate this into our curriculum? And one, it's not hands-on, it is a demonstration. Hands-on is up for the next session. Next FTP that we will have is definitely going to be on hands-on of experiential learning. So these are the objectives again. Same thing, they will be, the objectives are pretty clear as mentioned by JNM sir. So we will stick to it. Next, we'll start with what experiential learning is. It is a pedagogical method. Whatever we are trying to do is a pedagogy, whether it be traditional learning, whether it be any ICT activity that we are putting in place, everything is a pedagogy. But the way this pedagogy is structured and delivered is different, and it involves more of the student than the faculty. Faculty is no more a teacher. Faculty becomes a facilitator as well as a mentor. That is the core agenda of experiential learning. And we all we understand everything. And before talking about passive and active learning, let me tell you, knowingly or unknowingly, all of us have been putting experiential learning into place. The only thing is we do not understand the jargon because they've all come quite late, or we do not give it a term. But all of us have been doing active learning for over a decade now in GRIT, and we should all be proud of it. But to take it a step forward and to make it post-COVID more specifically, because of the internet content being more and more, how do we lure our students to ensure whatever we are giving them is good enough for them to achieve the actual outcome? So that is the extent to which we have to go to make the active learning absolutely active. So the passive learning, we are not, passive learning wouldn't, I mean, the traditional, as you see, picture speaks 1,000 words. So a teacher teaches and the student listens. There's not much activity. They do ask doubts, but involvement of the student is much lesser. Whereas active learning on the other side, where because the student is completely involved, I don't think I need to define them, because all of us have been involved in ICT activities quite well. So I wouldn't be defining them at all, but let us see the pros. It is absolutely structured And it has a very systematic approach. We have 5 units. We have mid 1 after 8 weeks. We have mid 2 after 8 weeks, and then the final assessment. And prior to the final assessment, we have lab externals, internals. Everything is absolutely structured, well defined. We have a beautiful curriculum that actually and that encapsulates all the required courses, and there's a percentage given to H&S courses. Everything is absolutely perfect, and it's been accepted. It's been accepted after testing for quite a long period. But we are not denying the advantages of traditional learning method. But having said that, keeping the student mindset in mind, not all students engage in traditional learning method. It's up to the student. The student might not be involved during the class. And when we talk about the traditional learning standard, if we stick to the textbook that is being given, we might miss out the points that are there in the industry. The industry is developing so rapidly, and there are a lot of disruptive technologies that are coming in place. So in order to uh, basically embed them into our structure, it is pretty important for us to have this experiential learning in place, because all these experiential learning techniques or approaches address the uh, open-ended problems or the sustainable goals that we look forward to, that are mentioned by principal sir. And and everything else that the industry 4.0 and the upcoming industry 5.0 basically demands. And as I said, we have a lot of students with different backgrounds. People come from traditional backgrounds and rural backgrounds. So traditional learning might not cater to each and every student, whereas active learning or experiential learning definitely does cater to all students, because we ensure student involvement. We are not teaching. Teacher is no more a teacher, as I mentioned earlier. We are facilitating, we are guiding them to understand the concepts in a better way, rather than making them to learn things in a very rudimentary manner. And we obviously require, for traditional learning, in order to make it more active, we need a lot of resources to implement. Whereas the experiential learning, along with the tools, with the ICT tools, it requires the cognitive abilities of the facilitator as well as the student to open up and to lead up, to have better critical thinking. Critical thinking come into picture. And talking about this, as I've mentioned earlier, there is a paradigm shift that Director Sir has already mentioned, and it's high time that we adapt to it. That it's high time that each and every faculty own it. Unless the faculty owns it, unless the faculty comes out from the fact that they are no more teachers, they are facilitators and they are mentors, we will not be able to achieve this experiential learning. We will not be, it is uh, the student learns, but it's up to the faculty to ensure the student is learning absolutely and is navigating in the appropriate direction. So experiential learning, as I've told you earlier, it bridges the gap between theory and the real world applications, and it obviously cultivates critical thinking and problem solving skills. I personally believe that the way we change a question, the way we put forth a question, will definitely change the thinking attitude of a student. And initially, it is we who have to master that questioning. No offense to anyone. I think we need to push ourselves a little bit, and then we have to bring in the higher order concepts while we are teaching. We have to bring in the social and the emotional learning concepts that are there in the that are happening in and around our vicinity. We have to bring in the problems. We have to address the social problems. That is when the overall learning of the student happens, and we will be able to touch all the 360 degrees. So as experiential learning is not easy, especially when it comes to, when we talk about the teacher, there is a lot of effort that the teacher will have to put in when it comes to experiential learning. There is a lot of time that we have to invest. If at all, from an I see that in order to deliver a 1 hour lecture, we need to prepare for 6 hours. That is what I have witnessed over the 20-year teaching experience. So 6 hours of complete study is what is required from my end. 6 hours of deliberation is what is required to put up 1 hour lecture. So that is only teaching. So just imagine if you have to come up with a structured teaching where you have different assessment strategies in place, weekly assessment strategies in place, and then different questioning patterns. It consumes a lot of time. We need to put in a lot more blood and sweat into our thinking abilities, into our functioning abilities, along with the technical questioning, in order to bring experiential learning in place. But trust me, it's all worthy of it, because there's a significant difference that you will see pre and post experiential learning in the students. And when I say, I say it only after implementing experiential learning for my students. And that's why I can concretely say that it is having a well-structured, a decently structured approach will definitely give you results. The only thing is the methodology has to be followed very stringently. The methodology in which we put PBL or PJBL in place has to be followed very stringently. Next, this is something which we have already talked about, the assessment style. I would want to concentrate more on the assessment style, because we all know that we are moving from teacher-centered approach to learner-centered approach or student-centered approach. We are becoming facilitators and mentors and not just teachers. The assessment style also varies. We do not have the conventional exams and grades, but we assess a student continuously based on their performance presentations, based on the way they try to introspect the topic after they have learned it or after they have heard from it, and how they reflect on their introspections, and how the discussion among the peers is happening, and then the discussion to the next level goes forward, is what we are concentrating on. We are concentrating on the on the process. That is what is important more than the outcome. It obviously, at the end of the day, outcome is very important, but the process is what is of utmost importance when we talk about experiential learning. And we all know learning context is mostly theoretical and abstract. I wouldn't blame it on ourselves, on the faculty, because keeping the time crunch that we have in mind, that we have within 16 weeks, we got to give them from the basics till the end. It is quite difficult, and in that we miss the actual essence of teaching. Or sometimes, not all of us, please, again, no offense, but generally what I have observed is we tend to complete the syllabus. We have a lot of stringent timelines or rigid timelines that have to be met, wherein intentionally or unintentionally we miss out on what is actually required. We miss out bringing the real world scenarios in place pertaining to that particular topic, or we miss out giving a particular challenging question to the student, and because they need time to think on it. So, and time, because of the time crunch we have, we keep it to theoretical, we keep it to mostly theoretical. Yes, there is laboratory experience that our student is exposed to, but that wouldn't give 100% of the results, but because that is not absolutely continuous in nature. And most of the labs, and as I've heard from Mallikarjun sir yesterday, the labs and the courses, the lab course and the actual course do not go in tandem with each other. So that is also one more problem. There are a lot of things that we have to address, but initial kickstart is not difficult. And then the key components of experiential learning, as I've told you, it is process oriented. The outcome is not important, but the process is important. Obviously, active participation is something that we have been endorsing for quite a long time. From the minute ICT has come into picture, I remember 2012 is when we started talking about active participation. It's been there for quite a long time. We are still working towards it, and experiential learning is no different from that. And reflection is what is very important. Student needs to reflect on the work they have done, and they should be able to come up with better ideas than what is existing in and around them, than what is basically different from what is basically existing in literature. And adaptability, so it should be adaptability. I hope all of you understand what adaptability is. Moving on from the traditional learning concepts, like where teacher teaches the concepts and then we implement it, that has completely phased out now. Now we implement it and then we learn from the implementation. That is what experiential learning advocates. So strengths of experiential learning, I don't think I need to emphasize more on it, because we have talked and heard a lot about it. And as I've told you, the challenges are quite a lot when we start to implement experiential learning. Now, when I talk about, after mentioning this, I would want to hear from any of our participants who have seen a change, because post COVID, it's been a complaint from all our end that most of the students are not attentive in class, and we are taking a lot of measures to engage them in the class. That is the biggest challenge for the faculty. So, what is your experience? Have you knowingly or unknowingly put up this experiential learning into your course? Can I hear it from anyone in the participants, please? Let it be interactive. We always complain that the students are not interactive. So we cannot complain anymore if we say we are not interacting ourselves, and we say our students are not interactive in the class and not engaging in the class. So we have a lot of senior and newly joined faculty. Please open up. It's a beautiful platform. We have a lot of experts who can address on the issues that we have.
I think I'll break the ice by saying what I observed during COVID period is the students are not coming to the class prepared.
Yes.
They're not doing any sort of pre-reading of the information, that at least know the objective and come, okay, the area in which today's class is all about. So he comes with such an open mind, or maybe closed mind, I am not too sure. So he starts expecting what to get after sitting in the class. The first, another, this one is the attendance is sporadic.
Yes.
The same person may not come again. These two are the major observations that I have. I would like to hear more from the other teachers.
We are all peers. We are all here to share. Yes, sorry, I don't want to interrupt. I see someone talking.
Yeah, it's me, Dr. Madhavi.
Good
Am I
morning.
audible?
Yes,
Yeah,
ma'am.
good
If you
morning.
can turn on the video, it would be great, ma'am, if it is possible. I won't insist, but.
A little bit I have internet issue. That's why
Right,
I'm
right.
not turning on my
Right,
video.
ma'am. Please, please.
Yeah, good morning to all. Regarding this experiential learning, I have one example, the way I have given assessment in last semester. So I was teaching design and analysis of algorithms for second year students. So instead of giving the routine questions, I have given one assessment in everyday life, what kind of algorithms we come across. And I asked the students to prepare 5 slides of PPT and present it in the class. I observed that almost all in one section itself, for 30 plus new algorithms the students have explored and they have presented. What kind of algorithm the Uber is using, the algorithm behind ChatGPT, the algorithm behind Zomato, Swiggy. So many such kind of examples students have explored and they have presented. So I had some confidence that, okay, I can explore few more such kind of assessments, and students will be responding more while giving the regular questions.
Absolutely, ma'am. That is so true. And when we were discussing the other day, JNM sir also told the whenever you're teaching a course, please address the social context. Bring the social context into picture. That is what he tells us all the time. Whoever interact, I'm sure you also have this experience, ma'am. Thank you very much for sharing, and it's a very worthy and a relevant experience which all of us should also follow. I see Karuna madam.
Thank you, ma'am. Thank you.
Thank you, ma'am. Karuna ma'am, very good morning. Any experience that you would want to share, ma'am? You have a lot of faculty in the department who are new. You must be hearing a lot of problems from them in regards to teaching and learning process.
Good morning, ma'am. We implemented small case studies related to society-related case studies.
Okay.
As a part of the curriculum for each chapter. So how it is implemented after that ending of the chapter. So
Okay.
society-related case studies we implemented in class.
Right, ma'am. That's also a beautiful thing. And sir, you want to share a few things, sir? Muti, sir?
No, you finish.
Yeah, I'm done, sir. I'm done.
Madam has just raised that social emotional intelligence. I thought I should give a simple example. Suppose I'm trying to teach, I'm giving a school example so that you can relate it with our higher education as well. Suppose I'm teaching students about subtraction. If the total distance is 25 kilometers and you have covered 18 kilometers, how much distance is left? So this is a simple taking away problem. So 25 minus 18, 7 is the answer. But the same question, if you want to give it, including the social emotional intelligence, considering the fact that we are in this SDG world, sustainability world, I say all the waste that is collected in Hyderabad is dumped in Jawahar dump yard, which is 40 kilometers from the city. So a truck is going to the Jawahar yard. It has covered whatever 32 kilometers. How much distance is left over? So if you can relate it to that existing one, now pause for a moment and focus on that subtraction part of it. But after that, spend a minute or two to say what is Jawahar Nagar, how much waste is collected in the city, and how big is the problem in order to collect and dump it there, and how you actually do that recycling or the 3R parts of it. So this way, the maths part of it gets included along with the social, emotional, and then your duty as far as the recycling is concerned in separating the wet and dry waste. So this type of bringing in the societal aspect of it and emotional part of it and reminding the people about the civic responsibility, you should be in a position to combine it with any topic that you are teaching as far as the class, whether it's a technical or a non-technical one. This is what Himabindu madam, she means by social emotional intelligence have to be integrated into our subjects. Thank you.
Thank you, sir. Coming from the person who can articulate it pretty well is more important. So thank you very much for that. So going forward, so whenever we talk about experiential learning, Kolb cycle, it has been, the word is tossed by David Kolb. There are a lot of psychologists and who have tossed these terms of experiential learning, learning by doing. But experiential learning has come into a more structured form in the year 1984 when David Kolb has introduced the Kolb's cycle. So he says an entire concept can be integrated into these four cycles. The first one is the concrete experience. Concrete experience is feeling what we have in and around, is observing the surroundings around us, looking, going through the literature, and then trying to implement something directly. We are not talking about, if you see in the traditional learning, We learn the concepts. We start with the definitions. Then if you see, we remember, we understand, then we apply. Here, we start the application first. We apply it first, and then we reflect or introspect as to what we have done is right or wrong. There is a risk that is involved, but learning by doing is more important over here. So we start by doing here, and then the student learns. So the first is the concrete experience. We try out something. Whether we fail or whether we succeed is very different. That reflection will come in the second stage. Then after the concrete experience, we reflect on our observations, and we see where we went wrong, what are the problems over there, and then we start addressing the problems by emphasizing on the strength of the project, the weakness, and what challenges they come across. And then we have abstract conceptualization. We have implemented something, we have reflected on our mistakes, and amalgamating the two of them, I might come up with a new concept altogether that is not existing in the literature, or it might be answering some open-ended problem that's always been there in the society. You never know what surprises we can come across once we start doing this. And then we come up with a concept where thinking comes into picture. First one is feeling. Next is watching, and then we introspect what is happening. The third one is abstract conceptualization. That is where the actual thinking happens. And then we compare our current experience with the already existing experience, and we come up with a new hypothesis altogether. Sometimes we call it a problem statement, sometimes we call it in the name of objectives. We've been doing all this all along, no denial on that. The only thing is the methodology in which we go forward has to be slightly different. And then we start the implementation. That is the fourth one, active experimentation, complete implementation. So to take it a bit more forward, I'd like to explain it with an example. So there is one, sorry about that, there's been a, which slide are you all able to see? Are still in the Kolb cycle?
Yes, ma'am.
Yeah. Do we see a table on the screen, ma'am, now?
Yes, ma'am.
Okay, thank you very much for that. So this is, I have taken one active scenario on basically a simple IoT project where I want my student, I think there's one slide that I have missed in between. Yeah. So this is the scenario that we are talking about. I want the entire classroom scenario where this is one problem on smart irrigation system using IoT. I have taken the concept of IoT because I believe all the faculty who are there in the meeting are from different disciplines, and all of us understand IoT better because we've been doing problems based on IoT from quite a long time. So I've taken this example. So in an IoT course, I've just given a mini project. It's a course where I've just tossed a question to my students to design and simulate a smart irrigation system that detects the soil moisture and automatically controls water flow using some XYZ microcontroller. Okay, and the cloud-based monitoring has to happen. So how do we basically map this onto Corp's experiential learning? First is we have seen four different cycles. The first one is the concrete experience where the students work hands-on, direct implementation. No wonder the students have least understand. I won't say zero understanding. They understand what a microcontroller is because once some term is tossed, they'll see what a microcontroller is, they'll see what a sensor is, but none of us is being taught out by us in the class. Students directly jump into the project or the problem, and then they start building the entire system. So in our real-time projects, last semester, I've seen a lot of students work on microcontrollers and sensors and IoT-based projects where those courses were not introduced to them in the syllabi by then. So, but still they started working on it. And after learning, they started understanding different concepts of IoT and different concepts of sensors, etc. and cloud also. So that is the first one is the concrete experience, and then is the reflective observation, where after implementing, the students understand there might be something wrong with the pin diagram, because if the build system is not working properly, if there are connectivity issues, then if the errors pop up, obviously it is for them to do the error correction or debug the entire circuitry. So then they start thinking, then they will go into the depths of the data sheet. Then they'll see what are the pin diagrams. Are we correctly allocating the pin diagrams? Do we have a proper, if is the input output not properly in place? Did we use the correct sensor? Is the sensor taking in analog values or digital values? Or is there any connectivity issues to the cloud? Wherever there are issues, then they'll start introspecting on their built project, and then they will discuss this project among their peer groups. They'll start reflecting on it, and then they will discuss it amongst the peers, and faculty, the facilitator will also be a part of it. But we will be observing, I wouldn't say we are there, we are in support of them. They are completely supporting them, but not directly involved. We are not directly involved. We don't give them what is required and we ask them to implement. We help them in implementing it. And then they come up with the abstract conceptualization, that whatever they have put in place, whatever the errors they have debugged in the second step, the third step is where the understanding of the theoretical concepts come into picture, which is not endorsed by our conventional learning procedures. Learning by doing is what we are saying, and the first step is learning by doing. Right from the first step, we do it and then we learn. So students relate their experience to the theoretical concepts, and they understand what a sensor is, what an actuator is, what an ADC does, what should be the characteristic of that particular ADC to be included into that microcontroller, what cloud platforms can be used, how do we manage with the current and voltage ratings for that particular circuitry. All these things come into picture because they've already experienced it. Having experienced it, the theoretical concepts become more and more concrete. So the methodology here that we are talking about is learning by experience over here. And finally, active experimentation. After doing everything on the three processes, they completely reconfigure or revise their system or model. This is not restricted to hardware alone, because I felt IoT is more of a relatable subject to all disciplines. I have brought concepts of IoT and ML into picture, and also having a bit of knowledge on IoT will give me an what do you say, advantage of being able to articulate it in a much better way compared to the other courses. And I want all the faculty to understand that we are not giving any course related information here, but the methodology that we have to follow and the experience we have to allow the students to have is different from the traditional teaching methods. That is what I want to emphasize on. So these are the four different procedures. And has anyone done something in these lines? Has anyone talked off in these lines? I just give you 5 minutes, or do you want to bring something in these lines in your upcoming semesters? Now is the time for us to have a small discussion. You can leave your, any question that you want to pose where you can make the students follow these four steps. I'd like to hear it from our faculty.
Good morning, madam.
Good morning, ma'am. Please introduce yourself, ma'am.
Yeah. I'm Dr. Parameshwari from H&S department.
Good morning, ma'am.
As a faculty of environmental science, ma'am, I
Yes.
do integrate this experiential learning in the form of a debate or a short film in the course,
Perfect, ma'am.
like how the plastic collection, the water management, and the waste management according to the curriculum. So we used to ask the students to debate on yourself. Like one group will tell about the positive aspects of environment, other will tell about the how technology is affecting the environment. So these kind of topics we included in the form of a debate or a short film. So what I observe is students are able to actively participate
Exactly, ma'am.
rather than this teaching and hearing the conventional method. So students are actively involving by doing. So that's what I would like to share.
Thank you very much, ma'am. That is the not that is the actual essence of what we are trying to do here. Give them a beautiful problem statement and then let them introspect on it. Earlier, we used to listen to what the faculty has to say, and then few of us used to think in those lines. Few of us are never bothered to think in those lines. So it
Yes,
is
sir.
not. It does not. Approach. It does not. What do you say? One to many is what we say, but how many are basically absorbing the content is not known. But having experiential learning or active learning strategies like how you have implemented will definitely cater to each and every student who's there in your class. And I'm sure you've also assessed them in those lines. I'm sure you must have had some questions during that tenure. You must have did that happen, ma'am? Questioning from your end during the reviews, during the
Yes, ma'am,
debate?
it happened.
Because that is what I feel in the entire my learnings from with PBL and project-based learning are completely aligned with the way the question is framed. Because the
Yes.
methodology changes with the question frame, the thinking skills change with the question frame. That is what I strongly believe in, and I congratulate on being able to implement experiential learning, ma'am. Anyone else who would like to share their experience? It's an
I have a question, ma'am.
yes, Raju sir, from your voice, if I'm not.
Yeah, I am Professor Baparaju from CSE department. Let me introduce myself. The question is, in these 4 blocks, where exactly the idea is you are inducing? Say, for example, without having a proper specification or proper idea or expected outcome, they can't go ahead with this hands-on, right?
Sir, the question I have just given some classroom scenario like this, sir,
And
initially.
then earlier blocks, you are showing 4 blocks. Now, just can you move back? I mean, you change the
Yeah,
slide.
yes. So
No,
or
yeah.
everything starts with a question, sir. Everything starts with a question, and I have given this question in my classroom, and I asked my students, I basically ask my students to implement it first, then introspect on their implementation, then they'll go to the theoretical concept of it.
Yeah, absolutely
At
right.
the
But
end of the day, outcome is the same. The process followed is different.
yeah. The point is to implement something, they should have something in their mind. They should have some expectations out of it, right? Then after they can learn in depth, that's the secondary point. But the primary point is without having a exact idea of what we are going to, what resources we need, and what we are expecting the outcome. So without
If
that,
I'm permitted
yeah,
to add,
go ahead.
Himabindu ma'am.
Yes, sir. Yes, sir. Casey, sir, please go on.
Go ahead.
Good morning, Babiraj sir.
Good morning.
So the point is, the moment we give a question to them, the problem, the complex problem we give to them, we do have step-by-step mechanism to identify what covers in the syllabus, what doesn't cover in the syllabus, what need to be discussed within the classroom, and what extra things the student has to cover by himself. Everything is in a scheduled proper way, sir. It is not like vague way we will give the problem and then we just wash our hands. They will struggle themselves, and even the outcome is not clear. Outcome is very much clear. The problem is defined with the idea of what actually we need. Accordingly, we will drive them. And once again, I would like to insist on the point that it would be a reinforcement learning mechanism. We don't exactly give the solution, but we will always tell them what is right, what is wrong. If they are doing something wrong, then we will correct them and ask them to go in a correct direction. That's where we act as a facilitator rather than as a lecturer.
Yeah,
I hope I answered your point.
Yeah, I got your point. But who is initiating the problem specification?
Sir, Baparaju
Obviously,
sir.
the faculty.
Yeah,
Sir,
Namaskaram,
I'll also add your this one.
Hey.
If you see the very question what Himabindu ma'am has given as a subject,
Hey.
the very first word is that, sir, in an IoT course. Already the objectives of the IoT course has been briefed to them. In this next 32 hours, I will struggle to teach you. There will be 2 meets, one final exam, 8 questions, all that.
Right,
And
sir.
at the end, you will be understand what an IoT is all about, which is a industry 4.0's latest advancement, all that. So
Right,
that
sir.
initial introduction and objectives are made clear to them. The
Yeah.
only difference is, instead of saying cloud and sensor and how deeply the sensors are integrated, digital technology has come into picture,
Yeah.
somewhere she will stop and say, now you learn. So your point is 100% right, but then she told in a very succinct manner in an IoT course. By then,
Yes, sir.
that initial part is over.
Right, sir. The thing is, initial part, here the question is, see, I mean, learning English doesn't mean that we can write a story like that. So the point what I'm not raise here is, in the 4 blocks, what we are saying, I mean, what I've seen there, see, problem specification is utmost important. Okay, we explain them how the sensor works, we explain them how the microcontroller works or the activators work. But at the end of the day, when they start designing the problem specification, which is a primary concept, they should have the clarity on that, which should be discussed. I
Sir,
mean,
sir,
yeah.
if I am
Sir,
permitted to add, process is a agile methodology process, iterative process, trial and error based also. Certain times people experience by doing something and they understand, okay, this doesn't fit, so we need to go for other thing. Now they'll explore themselves and try to pick up, for example, of this component, they'll pick up some component and try with that, and if it is not working, probably they'll go for the other one. This is what happens in case of problem based learning. Students do it and then they learn it, what is
Yeah,
correct and what is wrong.
Sir, I'll give a simple example, sir.
right, sir.
My niece is getting married in 2004. They
Yeah.
have in our community, there is nothing like a what is that Sangeet program and projecting that entire thing on the screen like a video at the back. I'm talking
Right.
in 2000, sir.
Right, sir.
So the problem given to me is
Hmm.
kindly project something onto the screen.
Okay, sir.
So I went around and found out that Flash is something which is most appropriate one. Being a mechanical engineer, not heard of Flash at all. I've
Okay, sir.
learned the Flash and made one video and put it there. So
Right,
I
sir.
don't require a complete definition of Flash right in the beginning itself.
That's true,
I
sir.
understood what is required and what is I can do it in PPT. I can do it in storyboard. I can do it with whatever, Studio Max. But Flash, I thought, is the most easiest one to learn and
Yeah.
it satisfies my requirement. What
Right,
you're
sir.
telling is the actual problems like in an industry, what you do, sir. There, the definition and the qualifications have to be pakka.
Right, sir.
Here, we are slightly at the initial stage, a different pedagogy of introducing a course to the student.
Okay,
We
sir.
are taking only those courses which we feel by doing, learning is much faster and more profound. Such
Right, sir.
ones we are requesting people to switch over.
Okay, sir. Okay,
Right,
sir.
right, sir.
Sir,
Right, sir.
to add on Bapiraju sir, that is the reason why I've pointed out I've quoted the course of real-time projects, sir, because
Yeah.
real-time projects are done in the second year, second semester, where our students are not introduced to what IoT is.
Okay.
They do not know what a sensor is. They do not know what an actuator is. There is no cloud that is there in the curriculum. But still at the end of the day, students are able to come up with beautiful projects. They
Right.
have. So that is my basic agenda. There is self-learning that is already inculcated in them. We are just taking it a step forward. That's it. I do understand that it is different from the traditional methodology, and it is difficult for us to adapt to it first, understand it, absorb it, and then adapt to it. It is a time-taking process, sir. But trust me, it's worthy putting it into practice.
Right, ma'am. Thank you.
Thank you, sir. So this is this is one thing, and I would want all the faculty to just think in those lines whenever we are asking our students, rather than directly teaching it. I suggest we go by these lines for the entire course. In this regard, myself and Dr. Krishna Chaitanya always have a debate. I ask, let us start with the concept. But he says we should implement PBL to a complete course. That is for another time to discuss. We still have our debates going on from the last 4 or 5 months whenever we talk about PBL and experiential learning. But it's up to us how comfortable are we with where it is better to start. This problem statement that I had given caters to the entire IoT course. I only thought about, it being to a concept, but if you see all in all, it caters to entire IoT course because I'm bringing everything into picture from the smallest detail to the end-to-end product as an outcome. So it's up to us to implement our cognitive abilities and then come up with questioning and please start preparing questions for your own courses that you would be addressing in the next semester, not academic year. We are not far from our semesters, probably a couple of days from now. So just come up with some questions which will address your entire course or a very important concept. Next, this is for my course and which I have not put into practice till now. This is what I intend to do in the upcoming year, and I don't expect all of us to understand this because it is signals and systems course. So this is how I have devised my Kolb cycle of experiential learning. So I'll be sharing the PPT wherein all of us can see how they have been. And I won't say this is the only way we can do it. This is one of the ways in which it can be done. There are multiple ways. All the roads lead to the same outcome, which is learning. So there are multiple roads that we can take. So at the end of the day, learning is what is important. As my slide changed, sir, Kasim sir, I don't see. So now, I'll have to request you to excuse me for a moment. I'll just share the screen again. There's been a problem. I'm not able to navigate my slides properly. So I'll just share it again if you just give me a minute. So I'll briefly talk about problem-based and project-based. I hope all of you are able to see my screen. Can someone unmute and answer, please?
Yes, ma'am. Fine.
Thank you, sir. Thank you very much. So problem-based learning and project-based learning are both basically address the open-ended problems or complex problems, but the only thing is the way in which they are implemented is slightly different. As JNM sir has mentioned, project takes a longer time because we are talking about a product or a prototype or a complete model which to be developed, whereas problem addresses a complex problem and a complex problem for which a solution has to be given. So I believe it can be, again, there can be contradictory thoughts to that of mine. I feel problem-based learning is a subset of project-based learning, whereas my peer thinks otherwise. He thinks that problem-based learning, because it's more complex, is a larger set, but I understand it in another way. I experienced it in a different way. So there is no hard and fast rule. There is no structure that has to be followed in which we understand the project-based and problem-based learning. So we solve a problem here in problem-based learning, whereas project-based learning is about creating a product. There is a redundancy in this just to cater to each and everything and just to bring in keywords. I have used multiple statements which talk about problem-based and project-based. We will understand it better with an example. Next, this is something which is very important. Both are multidisciplinary. Both problem-based or experiential learning, or even as a matter of fact, our NEP endorses multidisciplinary multidisciplinary courses or multidisciplinary projects, and it is not different with experiential learning or problem-based or project-based learning. cross-disciplinary, which involves concepts from a variety of backgrounds. I'm sure whichever course you take, if you're teaching a machine learning course, you have to have the concepts of linear algebra, which is from the maths discipline. So it is cross-disciplinary. Whenever we are trying to implement something, we have different disciplines, and the outcome becomes more beautiful when we have faculty involved from different disciplines. And both the problem-based and project-based learning focus on open-ended problems. That is already discussed by Dr. Jandyal and Murthy Garu, so I wouldn't be emphasizing much on it. But as I've told you, the approach is slightly different, and we will see how problem-based and project-based learning are different by taking the same example. I've taken the same example. I would want to emphasize on the way in which we approach is. So the theme that I take is intrusion detection using IoT and machine learning. And I'm sure that most of us understand IoT, and ML is just an added addition because most of our peers are from CSC and allied branch. So the project title, as I've told you, it is directly given: design and deployment of an IoT based intrusion detection system using machine learning. So I have clearly mentioned that I would want to see a IoT based product. So they will need to come up with a PCB which has a microcontroller, and that microcontroller should be interfaced with certain amount of sensors. Depending on the need, the tasks in the project, and again I'm stressing on it, it's not necessary that they stick to only these sensors or this microcontroller. This is just one of the examples that I am bringing forth. So we interface the microcontroller board with a PIR sensor, ultrasonic sensor, and camera sensors. Because we are bringing machine learning into picture, camera sensors are inevitable, because computer vision and the ML models will be employed in order to have a perfect learning outcome. And the microcontroller here used is ESP32. I hope all of you are able to relate. I'm very sorry if you're not able to relate. I thought this would be the easiest example for all of us to be able to relate. So Firebase is one of the cloud platforms. There are multiple cloud platforms. In GRIT, in our IoT lab, we use Firebase as the cloud platform. There is Blinkit, there is Things app. There are a lot of other cloud platforms, and the student and the other faculty are also free to use whichever platform is available. And the next is collect and label data. Whenever in order to put an ML model in place here, either we take a data set that is available publicly, or we create a synthetic data set. In this scenario, we are creating a synthetic data set. Whenever we create a synthetic data set, we need to have a label to indicate whether that procedure is an intrusion or not, depending on the features that we are collecting. So we need to label it, and then we need to train our model. After the model is trained, we will deploy the same model on our IoT module. We will deploy it on our microcontroller module, and then we will test for it. We will test it. And that testing involves accuracy, latency, and talking about how many misses it has. So these are the entire tasks. I am sure all of us follow this when we try to implement projects. All of us look for these points in our students whenever they are bringing up their methodology. So this is what we look for. And when you talk about problem-based learning, let me just take you forward for the same theme. I would want you to showcase. And again, this is not the only problem statement that can be generated. We are free to generate our own problem statements, but I would want to emphasize on the way the tasks change and the level of thinking of the students change. So here, if you see, I have given a scenario. I have not mentioned anything related to what they need to do. Yes, it is mentioned in a very, in a very succinct manner, where a security system for a warehouse fails to distinguish between human intrusion and pet movement, causing false alarms. How can we improve the system using IoT data and ML techniques to distinguish real threats from non-threatening movements? So if I remove using IoT data and ML techniques, this just becomes a statement. There is no involvement of IoT, there is no ML. I'm not hinting the student on using anything or doing anything. It is for the student to understand that IoT has to come into picture and ML has to come into picture, because we are talking about human intrusion and pet movement. Obviously, the camera has to come into picture and we should be able to differentiate between human and pet. That critical thinking skill has to be inculcated in the student's head. That is our basic agenda. Here we are not giving a problem statement like how I've done in the previous slide. It's not given very explicitly. Design and develop IoT-based intrusion system. It is given in a very scenario-oriented manner. And the tasks, obviously. It is a problem-based solution. They must have developed the model, obviously. They must have done something related to project-based learning. And now I am posing a problem. And the tasks of this problem-based approach are different compared to that of project-based. Identify why false alarms occur. Firstly, we should be able to, as I've told earlier, human and pet movement has to be distinguished. For that, we should be able to label them. We should be able to bring the human and the pet images, and we should be able to train our model in such a way that it will be able to distinguish between human and pet, along with the other features that we have basically extracted. So we will be exploring. We might need to add additional features, because if you want the false alarms to completely vanish, so we need to add extra features like the gait. Probably the gait, the humans have a different gait. We walk on 2 legs, whereas pets have a different gait. They walk on 4 legs. The gait movement changes. The size of the human is different to that of. So we might be able to add, and this is just a hypothetical situation so that we have created. So we will be needing to add more features. This again brings about critical thinking skills in the student, because unless and until we add these features, we will not be able to have a proper diagnosis, or we will not be able to optimize our model. And then we need to choose a suitable machine learning model. I'm sure there are experts who can choose a proper ML model and then implement the same. Should we run it on edge or cloud, depending on where the location is? If the location is the remote location, then we'd be choosing edge computing. And if the location is somewhere where internet is abundant in nature, then we can choose cloud computing. Edge and cloud only differ in terms of latency. I wouldn't go into the technical aspects of it again. So, and then text the concept using real or synthetic data, because we will be deploying the model again onto our IoT board. We need to test it. So either we can test it giving some synthetic data, or we can give the real-time scenario using the camera sensors and ultrasonic or whatever sensors we are using, and then we can test it and validate it and check if our errors are reduced. So if you see, this is something different from the conventional methodology that we've been doing all along. And I'm sure this will dig deeper and ensure the student has a different level of thinking. And this is when I say the questioning matters. The questioning matters. The questioning changes the complete aspect of learning. And I insist on the faculty to change the style. We start questioning the students, whether it be me or whether it be you, and all of us should change the questioning style in order to incorporate those critical thinking skills into our students' head, which is much different from the conventional and the traditional way of teaching. Any questions on this so far? I hope I was able to make the clear distinction between project-based and problem-based learning. Right. So here, as I believe, problem-based learning is a subset of project-based learning. I would give only 1 to 2 weeks in order to implement the project-based learning, whereas my entire project takes a longer time. So starting with this, I will talk about the last 3 points. I wouldn't want to talk about the first three because that is something we've already understood in the previous example. The student mindset. In the first scenario, the student is a developer, and whatever module they develop, they integrate it, whether it is the IoT module or whether it is the ML model. They try integrating everything and they try to develop a product. Whereas in the problem-based approach, we are bringing introspection into picture. We are bringing critical thinking skills into picture. We are making sure that there is an investigation happening and they are justifying their given solution. So if you see, both of them obviously talk about the Bloom's levels right from 1 to 6, but there is more emphasis on the higher order Bloom's level when we talk about the problem-based learning. The thinking process is different, the way they come up with solution is different, and the way they justify it is different. So I pose the same question to the entire class. I don't give different questions. I don't give different project titles. I pose the same question and I see how many solutions the students come up with, the way in which they come up with the solution, and I critique it every week in the reviews. As I told you, it is a very, the facilitator plays a very major role in supporting the students project, in critiquing the students project, and then in giving absolute good solutions to the, suggesting good solutions to the students if at all they are stuck somewhere. We are always there. Without a facilitator, without a mentor, uh, putting PBL and project based and problem based learning is impossible. It is for us, the students self learn, or we direct them to self learn in the right path, and then we hold their hands right from step 1 to step n without them knowing that we are holding their hands. That is the beauty of this experiential learning, where we being facilitators and mentors and supporters play a very vital role. Okay. I just have one more curriculum and then we'll move on to a case study. If anyone has any questions, please feel free to unmute yourself and ask. So curriculum integration and institutionalization, as I've told you earlier, NEP 2020 also advocates experiential learning, and as it become, as the outcomes are more abundant than compared to the traditional learning, and as we've already stressed on, it is outcome driven education, not outcome way. Outcome only is not important, but the process is important. It is cross disciplinary, and it will also inculcate critical thinking skills, and we will also emphasize more on the students working on the real world scenarios, like how principal sir and director sir has mentioned. Posing a question is very important. There are different ways in which we try to assess them. The assessing method is different, the way in which feedback is taken is different, the frequency of taking feedbacks is more compared to the actual ones, and the methodology of assessing them is different, which we will see in the upcoming case study. I'll quickly take a 2-minute break and then I'll come back with the uh, next presentation. If you have any doubts, please feel free to answer. We have half an hour more in the session and then we'll conclude it, and we are open for questions then, or either you're free to ask questions now. Right. So this is one project-based learning or problem-based learning. It changes with the way in which the question is framed, that as we have seen in the previous slide. And there is a reason why I've added hybrid. Depending on the student segment that I've had, I felt hybrid problem-based and project-based learning would be more advisable. So I followed that. So we'll just go forward and have a look at what I have implemented for my students in the 2024-25 academic year in the Internet of Things course. So I've given a scenario over here where a homeowner X, it's not a very complex problem that I had given. After introducing what IoT is very subtly, and then after telling them what are the outcomes and objectives of the course, and slightly giving them an idea about what a microcontroller is, and they already have the prerequisite that has to be learned. Microcontroller course is already completed, so they have a fair knowledge about the microcontrollers. They do not have any idea about what a sensor is, what an actuator is. So these things are new to them. So a very subtle introduction to all these concepts. And then I've given them this scenario. A homeowner is frequently away for work and needs a security system to monitor unauthorized access to his home. His primary concerns include unauthorized door and window openings, and motion detection inside the house, alarms, remote alerts, and real-time monitoring. This is the scenario I have given. I have not made it very complex because I didn't want the students to panic. So I made it very simple. So if you see, I did not mention anything related to IoT in this. I've not asked them to use, there's no smart that is included over here. And neither there is any machine learning that is included over here. I've not asked them to follow a particular path. I've not asked them to do something. I've just given them this scenario. This is the problem that I have given them. And if I were to implement project-based learning, then I would be directly giving them the title in this format, Smart Intrusion Detection System for Secure Home. So this title I would be just giving them, and I might as well ask them to come up with multiple solutions for the same project title. Okay, these are the two different ways we can put forth. And why did I say hybrid? As I've told you, there is basic theoretical principles have to be understood, as Bapiraju sir has pointed out. So after the initial introduction, I did not want them to dig deeper into the course because if I were a student, I would be just digging deep into the theoretical principles, into the fundamental aspects, rather than implementing it. I would still be learning what a sensor is, what an actuator is, and know the difference for about 2 to 3 weeks. And then out of whether interest or out of curiosity, I will keep digging deep rather than implementing it. So I've initially given them some inputs related to the fundamentals that they need. And we've also requested a few faculty from cross-discipline to help our students out in regards to developing the product actually. So and this is something, this is the reason why we have come up with a hybrid model rather than a complete PBL model, because the teacher had initially, I have given some inputs related. I have not just given the scenario and I have not asked them to work towards it. So the course instructors, as we talk about, we have multidisciplinary. Unfortunately, we were unable to involve students from different disciplines as it was related to a course, but we were able to involve faculty from different disciplines, from faculty from electronics and communication engineering, computer science engineering, and mechanical engineering were involved in order to come up with a product. And that is the basic essence of what experiential learning or the NEP 2020 basically endorses. So why are we looking at multidisciplinary? As I told you, I am an expert in my domain. It's not necessary for me to have a complete understanding of the expert, or for me to be an expert in other domains as well. So I might be a jack of all trades, but I needn't necessarily be an expert in all the trades. So this is why we need to bring in experts from multidisciplinary, because all the jobs that are required are done to perfection. So it encourages a complete holistic thinking, because whatever elements I am missing on will be completely padded on by the other discipline faculty. And it encourages active communication and knowledge sharing. They will have a knowledge about what a sensor is, how are we implementing, how do we integrate the sensors with the microcontroller, and in which way mobile app and cloud integration happens. All this knowledge sharing will become perfect when we have multidisciplinary faculty or the students. And if at all we talk about students, obviously at the end of the day, the basic outcome of the entire program is for the student to have quality education in a holistic manner, so that they are ready for the job, so that they are able to put up everything that I've learned, that they have learned in the 4 years in their job. So that's this multidisciplinary environment will help them mimic the real world engineering problems, because not all ECE students will sit in one place and will work towards it. We have people coming up from different domains, so that exposure is also given to them in order for them to make sure they are employment ready. There are multiple other factors, but I feel these three are very vital when it comes to multidisciplinary projects. There are a lot of other things, and I would welcome the faculty, if they have anything else, they can please put forth, and we can start thinking in those lines as well. So this is how I have completely devised my course, or I have completely organized my course. The first 3 weeks is PCB fabrication. The students do have a fair bit of knowledge on PCB fabrication, as they had undergone this in their second year first semester and second year second semester. They would need to come up with PCB boards that are relevant to the current project only, but the theoretical content that they would need to understand and the learning outcomes are clearly mentioned during the course organization, so that we can check, we can tick it off whether the student has achieved the proper learning outcome or not, is something for us to tick it off and ensure that the learning is complete. I have given the learning outcomes for every module. This might not cater to the students, but whenever we are doing the reviews, have the learning outcomes completely being met? Is the student aware of the theoretical concepts that are to be completely laid out in order to understand the experimentation? Is something that I have comprehensively done for one course of mine. So it's up to I felt that this was much easier for me, because I can just keep ticking boxes for each and every student while doing the review. Likewise, after 3 weeks, 2 weeks is for 3D modeling. If you have to house your project, you might be needing the 3D enclosures. For that, we have also introduced 3D modeling, which was catered by mechanical faculty, and the microcontroller boards and development was taken care by ECE faculty. 3 weeks, I'm not emphasizing more on the theoretical content and learning outcomes, because they cater more to electrical engineering people, of the circuit branches, more of circuit branches and a bit of mechanical. So that's why I'm just let us understand the process and not the content over here. My total request is for you to understand how we are organizing it, and how we are reviewing it, and how we are assessing it. That is the total that is the main objective of this session. And then same 3 weeks of introduction to embedded systems. The student will be self-learning here. Please let me tell you, because I've put hybrid in picture, the facilitator can also induct the students on the theoretical contents, and there is also some self-learning things that happens over here. So it is a hybrid model, self-learning as well as help from the facilitator. And then the next unit, fifth unit, is mobile application, which is completely self-learning, and the students enjoyed this the most because mobile application was the most fun part for them, where they got to understand the concepts and they were able to easily work it out on their own without the faculty's help. And likewise, the cloud connectivity, this was given for 2 weeks, all thanks to the computer science faculty for helping us in achieving this, the cloud connectivity. So these are the 5 modules that I have. And again, let me tell you, okay, sorry. Let me tell you, it is not necessary. I have divided my 16 weeks in this way. And then I have made sure that the theoretical contents that are there in my syllabi are completely covered. And then the learning outcomes are clearly given so that I can, while assessing, it is easy for me to tick them off. So this is what my basic agenda is. And then the course outcomes, this we've already talked of. I will not be emphasizing much on it. Basically, the course outcomes is to design and develop this. I have tweaked my actual course outcomes a bit to bring it into 3 rather than 5. So again, project stages. That was very comprehensive one that I had. And here I am, when I'm trying to review, I keep that on the background and this is the foreground, because if we give that entire set to the students, it will be very intimidating. So I have divided the project into 4 stages. The first one is PCB fabrication. PCB is how, I hope all of us have IoT lab in our departments. The board on which the microcontroller is basically stuck onto, along with other interfacing, is the PCB board, and the students will be fabricating it right from the scratch. So that is what printer circuit board fabrication. It is a 4-step procedure, and that step, those steps have already been trained to the students in their second year first semester and second year second semester. Next is the microcontroller and sensor interfacing part. The programming, everything comes into picture over here in the second phase, as well as the third phase, mobile app development, and final phase is the cloud connectivity. With all these 4 stages, I believe that I will be able to develop a model which will do what is required, what my basic project statement or a problem statement or the scenario that I have given is met. And it is not, and you can devise different stages according to you. And I've taken inspiration from literature paper which has been implemented by Dr. Devika Kataria, who's an ex-faculty of GRIT, and currently she's an associate professor in JKL University of Rajasthan. So she has been an expert in PBL and project-based learning, and she's had international exposure as well as nationwide exposure. I have taken her work as an inspiration, and I've developed mine. And there are multiple other ways in which we implemented the, as I've told you earlier as well, there are many roads that lead to GRIT. The path is up to you. Whichever path you take, the entire the end outcome is learning of the student. That is our basic agenda. Learning by doing is the basic agenda. The path you take is up to you. It has to be, it is not necessarily, there's no particular structure that is being posed for PBL as such. Project-based learning is much more structured, but for problem-based learning, there is no structure as such. So it is for us to design the structure and then follow it accordingly depending on our abilities. So again, please ignore the blocks over there. Please concentrate on the emphasis level, the percentage that is being given. So first one is PCB fabrication, where we will be designing a customized PCB board for intrusion detection, and we will be integrating all the microcontrollers. Again, whatever deliverables I have kept in the previous slide, I have just brought them over here. There's nothing new that I've done over here. The same things that I have brought them forth here. And the category, every stage will have these categories: domain knowledge, content learning, hands-on skills, analytical skills, real-world application, teaming, and collaboration. By doing this, we will be enlightening ourselves as well as the students as to what different skills they are learning and what is the emphasis level they have to put in order to do certain activities and achieve certain outcomes. So these are the 4 stages. For every stage I have the same categories: category, domain knowledge, content learning. For everything I have divided them into, and the emphasis level, and then the key deliverables. This is the second stage where programming, as I've told you earlier, programming comes into picture. The third stage where mobile app development is, and the last stage where cloud connectivity has come into picture. So this is something that students implement and learn while implementing. In all the 4 stages, if you see, whatever the course outcomes or the course outcomes that we have, everything is achieved in every step of their doing. Every step of their experience, each and everything is achieved thoroughly and in depth. That is the basic agenda of it. And obviously, we need to have a very stringent review system. The implementation has to be very strict, and the faculty has to be there throughout. And as mentioned, there are a lot of challenges. First thing is absenteeism of the students. But as our faculty has shared, Madhvi madam has shared, once we put these learning practices into picture, student will will automatically be driven, or else we just hope that they will be driven to the classes on their own, because the learning methodology is different and the thinking styles vary, and they would need, their involvement would be necessary in and out. So this is the rubrics. I'm sure all of us understand what rubrics is, because we have this in place, and it is a continuous assessment. All thanks to continuous assessment that is already included in our curriculum for every course, as well as GRIT lab on board activity that has good number of marks. So I was able to implement this perfectly because of the continuous assessment, and the block marks that were given were directly related to this. I made sure that there is a connectivity between the marks and the way in which the student analogous to the way in which the student basically performs in their class. So these are the rubrics that I have devised. Again, it's not necessary that you follow the same rubrics. It's just up to my understanding that I have devised these rubrics, taking help from the ACT developed rubrics over the last few years. I've taken inspiration from them, and I've developed these rubrics here. And accordingly, I have given the marks. If you see the weightage percentage, 20%, and every classroom participation, 15%. 15% of the quizzes, because we cannot sway them away from the regular curriculum or regular teaching methodology. So quizzes are very important for them, for us to ensure that they have understood the theoretical side of the concept as well, and different stages. This is because every stage is very important. 30% of the weightage is given to all the 4 stages of the project, and final project and presentation. Here we are looking at holistic thinking and holistic implementation. So even for a lab, I made sure the students come up with a final report as to what they have done throughout the years, and I strictly made sure that every week they come up with a detailed report, so that phase-wise reports are verified, and because they are time consuming if they give it towards the end. So phase-wise reports were advised to be uploaded into the Google Classroom, and once they have uploaded it, there was a review. Every time they upload, there is a review that happens. The questioning happens, the critiquing happens, and then finally the solution giving happens amongst the peers and along with the facilitators who are sitting for every stage. So these are the rubrics that have been devised. And as I mentioned, feedback is a very core component of experiential learning, because we need to understand the perception of the students, and we need to align ourselves or reconfigure ourselves. I would put this word reconfigure ourselves to suit to the students' students' thinking or students' requirement. So the perception of the students, I thought, okay, implementing this, I would be getting a perfect 100 on 100 feedback, because I've done something which none has done, and this is a very different thinking process. There were a lot of thoughts that were running in my mind before I actually took the first feedback. But once I've seen the feedback, yes, it is very difficult to basically ensure the students' learning is perfect. The feedback, as you can see, it was mixed. Please don't expect 100% feedback from the students. This is a new learning concept. They're not used to us weekly. They're not used to weekly review. We do weekly reviews, sorry, but the weekly review that we do in experiential learning is what matters the most than the regular teaching methodology, than the regular facilitating methodology. So the reviews, the student, initially they had an inertia. Initially, a lot of inertia was there. They were not happy. Ma'am, why are we doing this? Sir, why are we doing this? We don't want to do this. Why can't you just give us the material and we will produce, we will do the experiments, weekly experiments. There was a lot of inertia, and there was a lot of retaliation from the students. But slowly they got used to it. Once we insisted on them understanding the entire procedure, they have slowly come into the I mean, out of box thinking of the students had risen somewhere 6 weeks after. I think it took them 6 weeks to engage completely, and then after, they were absolutely cool with doing whatever the project was given, the problem was given in their own manner. Uh, so, as I've told earlier, 71 students, we have divided them into 13 teams, and every team had to come up with a solution for the given problem statement. You can give multiple problem statements, or you can give a single problem statement. It's again up to the faculty. And these are the end-to-end solutions. If you see, one intrusion detection system was done using magnetic switch and PIR sensor, and the other one was with ultrasonic sensor, magnetic switch, and the PIR sensor. Multiple solutions were given for the same problem statement. So the students understand during the road show or towards the end, the students were able to understand in how many ways we can interface the sensors, in how many ways we can basically come up with a solution. So this is what the essence of PBL is all about. It is learning by doing. It is introspecting. It is for the faculty to open the students completely to address the open-ended questions, open-ended problems that are existing in the society. And I'm all thanks to the RTP and SRP, RTRP and SRP that we have in our second year. That is a complete, I would say, a disruptive course which has changed the student mindset right from the very beginning, and the students are started to enjoy working because we ensured that they work towards the sustainable development goals. They include the concept of sustainability into their projects. They've come up with solutions and problem statements related to that, and every next step I hope they start to improve themselves day in and day out, and they become graduates with 100% quality, and be able to address the societal issues, and as along with the ethics that we have inculcated all through the 4 years. Thank you very much for your time and patient hearing. I'm open to questions. I see the participants are slimming down. So if there's any questions, we are open to answer. Our second speaker, Dr. Krishna Chaitanya, was unable to join because he was traveling. It's 12:23. We have 5 more minutes. Request.
Mabindu ma'am.
Yes, sir.
I can just add on for 5 minutes. I'm outside as you mentioned, but yes, I can add on for 5 minutes if you permit me here.
5 minutes it is.
Huh?
5 minutes it is for you then.
Yeah, 5 to 10 minutes. Yeah. Good afternoon, everybody. always there to share the knowledge, and I was very happy to be part of this particular training program that is happening for the last 3 days. I was insisting on this fact that our leaders are always looking ahead from us to take up this particular PBL practice and pedagogy and keep it into practice. Let's do it this semester at least, because it's been almost 2 to 3 years. Our leaders are asking us to move ahead. I would like to pick up a point from what JNM sir said a little while ago, regarding this drashta, manana, and other thing. Adding on to that, the point is Upanishad itself is making the person to sit nearby. The good old and school, the Gurukul practices, what they have done is like people are near to the teacher and teacher dictates something. It's all like oral transmission of knowledge. But the most important thing is the moment the discussion is done, what's now? This is the question what the student may get. The moment if the student gets what's now, it means the knowledge is not transferred properly. It should be very clear for him to do what to do with the knowledge what he has gained. Application of the knowledge, that is most important in this process. That is what PBL is all about. As what we could observe, if at all some astras were discussed by the guru, the candidate would go into the forest and practice it on some animals or somewhere in the open land. We can't correlate it with the small lab experiments what we are doing, because the real life problems are completely different. That's where the problem-based learning comes into scenario. We need to give a complex problem which makes the students to explore a lot, do the research, and the problem should have multiple solutions. As what at the beginning Principal Sir has mentioned the essential characteristics of problem-based learning. All those characteristics it should meet with. One example what I can quote here is Byron University, Western University has implemented this particular PBL for blockchain technology. As we all know, blockchain technology is a distributed environment scenario where the smart contracts are to be developed. But they have given a scenario like regarding the healthcare system, public healthcare system. The problem is data security for the public healthcare system. Now, it is not a project. Please understand, it is a scenario given. It is a scenario given, and students are compelled to learn blockchain. To implement that, they need to learn smart contract, building the smart contracts and deploying them. So this is all problem-driven approach, not a straightaway statement of the problem is given or the project is given. It's a scenario what is given for them. And one of the important aspects what we miss generally in the projects is we don't much concentrate on the data set that is being used by the students. Are the students taking care of the real data? Here I would like to add a point. It's better if we ask the students to develop a small data set and then use it, because that is what the real scenario comes in. The actual data comes in. Now, in that process, the student will explore. The domain exploration happens and he gains the domain knowledge, which is lacking in general when we speak about the project implementation. Straight away, he downloads some Kaggle data set and applies some machine learning algorithms, wherein he don't learn much in that process. But once you give a problem scenario, like what in this case, the student has to happen to go through a survey. They have conducted a survey and identified which data elements need to be secured using blockchain. Not all the information, like maybe in one of the cases, like the respondents were okay to share the data of their eye disease or eye and teeth related information, but at the same time they were not they were reluctant to share the data of their DNA and disease history. So this means that the student will come to know that okay, these are the two aspects for which we need to implement a PBL. So this is how we need to make them to think, explore, and then implement by learning themselves. Solidity is one programming language that can be used, Hyperledger framework and other things. So they are supported by certain online classes. By the time they have started, even online resources for less. So students were made to explore much. They need to work more and then practice themselves. All the way tutor would be there. Maybe like a flip class mechanism, we give some material to them and ask them to come to the class, and then we discuss, we identify what wrong is going on with their work. We try to guide them accordingly. So it's a facilitator, not just a lecture in the classroom. And ultimately, students have come out with such a scenario where they have implemented Solidity and it worked very well. I'm sorry to say here, I'm unable to show my PPTs because I'm out of place in some office. So this is one small thing what I can tell you. Obviously, there would be certain challenges while implementing PBL, but let these challenges don't be a hindrance for us to get into this. The course level objectives may be a little different if you want to implement the PBL, but still we can implement the PBL, giving some 2 or 3 marks in the assignment or somewhere. We can ask them to do all these things, and then we can support them with the support from the authorities very soon, and more structured way we would get. But I strongly urge each and every faculty member to start working in this particular PBL process. One thing what we would like to see is, we have already done projects, mini project or major project. Let's say major project. We will share one sheet which shows how the PBL course level implementation can be done. An example where we discuss related to the, for example, let us say land records. The land records need to be safeguarded. So this particular scenario we will give, we will not even, this is a statement what I have given is a direct problem actually. But we will give a scenario. The land records being fudged, we want a non-fungible, record structure to maintain this information, and they are distributed in scenario. Now, this whole scenario will make the student to learn about blockchain technology. This is an example for blockchain. Once again, the topic what I was supposed to discuss. So, in this process, we need to see how the problem is, whether the problem has got all the characteristics that are meant for a problem-based learning scenario or not. And then we need to check out a plan of action. What falls in the syllabus, what falls out of the syllabus. If something is there in the syllabus, then we need to support them while discussions or some other mechanisms, course material, or maybe Google Classrooms, or maybe like flipped class mechanisms, all the actual learning. See, everywhere we have this actual learning practice. And then the action plans, what is the first step to do? All goes in parallel scenario, not necessarily sequential. Maybe in case of land records, the person need to know about the details of the land records, how they are maintained, what they are called as, how the land is measured. This is all domain knowledge which is generally found lacking in case of students who do the projects. And then he also need to understand whether it is a private blockchain or a consortium level blockchain the person has to implement to safeguard this sort of land records. So that is another step that need to happen. Likewise, he goes on, like we as a faculty need to identify these steps, and students would go through those steps, and ultimately they have to learn the Solidity or whatever the programming language that is required for implementing blockchain, consensus and other things, smart contracts. They have to implement it. And everywhere, as what Himabindu madam was insisting on, the continuous rigorous reviews are important. If you say like after first mid I'll try to implement project based learning or problem based learning, the time won't be sufficient for continuous rigorous reviews, because it is all agile methodology sort of thing. In an iterative fashion we go on implementing it. So we need to start by the beginning of the course itself. As a faculty, we should come out with a suitable problem that addresses the concepts of the subject we are dealing, along with it has to meet with certain societal needs. Ultimately, see, it's as good as I have prepared a very good biryani, but nobody is tasting it. No meaning in that. So we need to serve to the people. Ultimately, we need to give it to some product, process, project, and product. This line we need to remember. Some product, if that is product is very good, probably people will go for entrepreneurship also. So this is all hands in hand. Design thinking, entrepreneurship skills, and project-based learning, or PPBL also some people call it as problem-based learning. All goes hands in hand, where this faculty need to work a little more ahead of the student and be ready. So maybe within 2-3 days you may not be doing it, but as what Himabindu ma'am was mentioning, in a fortnight or in a month, once again we will have a hands-on experience, by when we expect you people to come out with course level PBL sheet for the projects that you have implemented. Out of all the discussions what we have done in the last 3 days, now we expect you to prepare project for your project, that you any one project, because it is already done. Probably you will be able to identify, and it becomes easy for you to practice which can give you more confidence so that we can do it for the subject of the forthcoming semester. Maybe couple of topics or maybe complete course. That depends on to what extent the faculty is comfortable to implement PBL. By and large, we want PBL to be implemented. So this is what from my side. I think Himabindu ma'am, this is what I can do now. Thank you. Sorry for the trouble.
Yes, sir. No issues at all. That was well said. Thank you very much. And I could. Asim sir, would you like to share that PPT, the tidbits of PPL that has been shared by our director, sir? And while you're doing so, I request all the faculty to turn their video on so that we can have a quick picture before ending the session. And also the questions, any questions you have are welcome.
Madam, so far in these 3 days, we have discussed about the implementation of this PBL system. And don't think that I'm posing a discouraging question. First, defining a structure and system and making it familiarized to the faculty and then implementation. So making it familiarized to people is very difficult. We have very good experience with the COPOs. Now, finally, what COPOs has become, entering the marks finally. You understood me.
I understand you.
That can never happen with PBL, Kasim sir, because faculty are the one who need to come out with problems. I would say, see, demonstration of swimming will not work unless you jump into the water and start swimming. This is what happens with PBL. People have to work hands-on. Then only they will experience the process of experiential learning, and then they will be able to come out and implement for the students. It's not like a structured
Sorry,
very.
sir. Sorry. These 10 years, JNM sir and Dean FDPs, Dean Academic Affairs, they used to conduct training programs on COPOs. Course outcome means you have to start with this sentence, this term, and this term. Now, finally, it became you enter marks.
See, that is they have. I would say they have lessened our reduced our work, and they have taken care of it by automation and some mechanism of calculations automatically being done. That's a help for us actually by entering. You are forgetting about COPO calculation. Everybody should understand what is happening behind the screen of COPO calculation. That is very much important anyhow. But this PBL cannot happen so because end of the day we want students to work out on it. Unless we give such a complex problem, if you give a simple problem, yes, it dies very soon. And we cannot claim that we are implementing PBL. If you want to claim PBL to be implemented or being implemented at course level, program level, or industry level, I mean to say institution level, then all the faculty should discuss, like the common subject faculty should discuss and come out with problems and then give it to the student groups. It is not individual again, it is group wise. Ultimately, when multiple problems are coming out, it will happen, sir. It's not like I have designed a lecture schedule for PBL and then we have done it. We can do that, but initially, yes, we can just test the waters and we can work out on it. This is what I feel. Madam, you can add.
Managing computers or machines is easy, sir, than managing people.
Very true, sir. Kasim, sir, I completely agree with you. Having traveled with you for all the 10 years in GRIT, I do agree with you. But again, as I've told you, the outset and the mindset of the faculty and the students has to be different for us to be able to implement concepts like this. It's not experiential learning; it is also experimental learning. So it's up to us, and as I've told you, we are not experts in there. We are still getting there. We are trying to do something. So let's all try to do something, and let's all come up with a common plan where this will work. Because here, outcome is not learning. Outcome is the process. So don't worry about the course outcomes. It might. I don't think it will be sticking onto the paper or FTPs anymore. It will be implemented seriously in the upcoming semesters, and it is up to us faculty to ensure that happens.
We are an easy system, madam, not with a complex Excel sheet. Okay.
Okay, we'll try to see. We'll make.
Kasim,
Yes.
sir, just let me just add. there is a word called, it is better to be an optimist rather than a cynic. All of us tend to become cynical looking at the problems all over the place. You know, Abraham Lincoln, when he admitted his son in the school, he told the son, there are bad politicians, but there are good politicians who look after for the growth of the country. Same way, we cannot generalize, but then there is a need for all of us to move to optimism, because this becomes a habit. Then you will approach every problem, whether it's a family problem or official GRIT problem, with the same cynicism. You can't be a dual personality. At home, I am very optimistic. At college, I am highly cynical. Not like that. So let's have one rule saying that we are all optimistic. So when it comes to that COPO, if the teachers still haven't got saying that only one word, there is a Bloom taxonomy word in my objective. My pedagogy, I'll ensure that it takes, the content is prepared to that level, the delivery is made to that level, and the examination is done to that level. I think you have understood COPO concept completely. The rest of it, the computers and the entries, etc., they will take care of. But coming back to this one, like Bapiraji Garu was asking, I think all of us have to focus on that L part of it. This whole process is to learn. Okay, not solving a problem. Solving a problem is secondary. Primary thing is we are trying to introduce a new methodology. While solving, we also learn. So we'll focus on that now. Let us see. Everyone says it's a learning by doing is the most important thing. I have only those 4 lines. Somebody has told that, I'll tell you who told later. Learn to do, learn while doing, do it to learn. Anyway, you focus on those words. I'll come back. It's a big story. That's how actually we all do it unknowingly. We'll focus on that subsequently. But for the present, I think we'll hand over, continue with the process of closing the ceremony for today. Kasim, you continue with your your formalities.
Okay, sir. Thank you.
Now, what is it next?
Next, as we come to the end of this insightful sessions, it's time to express our sincere gratitude to everyone who made today's program success. I am now inviting Dr. Usha Kumari to deliver the vote of thanks.
While she is doing, you wanted all the people to switch on the cameras?
Yeah.
Yes, please, sir. I request all the participants to turn their cameras on for a quick picture. Kasim, sir, are you on it?
Yes, madam, doing.
Yeah, thank you.
He's getting ready. Amma, continue.
Okay, sir. Good afternoon to one and all. I am Dr. Usha Kumari, Professor in the Department of ECE, GRIT. It gives me immense pleasure to deliver the vote of thanks for today's enriching faculty development program on experiential learning with special focus on problem-based learning and project-based learning. On behalf of the institution and all the participants, I extend our heartfelt gratitude to our Director Garu for sharing the essence of experiential learning. And also our resource persons, Dr. V. Himabindu, Professor, Dean FDP, and Dr. N. Krishna Chaitanya Garu, Associate Professor in the Department of ECE, GRIT, for sharing their valuable insights, practical strategies, and inspiring approaches that truly deepen our understanding of learner-centered teaching in this 3-day FDP from 25th July to 25th June to 27th June 2025. A sincere thank to our management, Director Garu, Principal Garu, for their constant encouragement in organizing such transformative sessions. I also thank KNV Kasim for his dedication and seamless coordination that made today's event a grand success. Finally, a warm thanks to all the enthusiastic participants for your active involvement, thought-provoking questions, and commitment to improving the teaching learning experience. Let us carry forward the spirit of experiential learning into our classrooms, empowering students to become critical thinkers and innovative problem solvers. Thank you all once again.
Special thanks to KC Garu. in spite of your, I think the collector or MRO must be standing behind you. You must have learned what experiential learning is by now. But thank you very much.
On behalf of the organizing team, I thank our dignitaries, resource persons, and all participants of our for your valuable presence and active involvement. Wishing you continued learning and a wonderful day ahead. Thank you.
Thank you.
Feedback link is posted in the chat box. I request all of you to fill in the feedback link before exiting. It will be active till 1 o'clock only. Once we cross 1 o'clock, we are going to close the session. Thank you very much, one and all.
Thank you, madam.
Thank you, ma'am. Karuna, ma'am. Next semester,
Excellent
PBL.
session. Thank you.
Next semester anta PBL le undali mana AML antanu.
Okay, sure, ma'am.
Right, Andy. Hands on చేద్దాము. For every department individually, we'll come up with hands on to take it forward.
Sure, ma'am. Please share the PPTs, ma'am.
Right. I will share, ma'am.
Yeah.
పెట్టి HODs కి share చేస్తాను. Only HODs కి. You can share it with all the faculty members.
Okay, ma'am. Thank you.
Thank you.
ఆల్రెడీ ఫీడ్బ్యాక్ లింక్ వచ్చిందండి చాట్ బాక్స్ లో.
వచ్చేసింది సార్.
కరెక్టే. దీంట్లో
రాలేదా సార్? మళ్ళీ పోస్ట్ చేయమంటారా?
మరి చేయండి. ఇది దీంట్లో వేరేది వచ్చింది, ఫస్ట్ వచ్చింది. ఏది ఎస్ఎల్ఆర్ సెలక్షన్.
అవునా, ఫస్ట్ వచ్చిందా సార్? ఫీడ్బ్యాక్ ఫామే పెట్టారా కాసిం సార్? ఇప్పుడు చూడండి సార్ బాపరాజు సార్.
ఒక నిమిషం అండి.
రిజిస్ట్రేషన్ ఫామ్. అవును, కరెక్టే చెప్పారండి. ఫీడ్బ్యాక్ లింక్ కాదు కాసిం సార్.
అది రిజిస్ట్రేషన్ లింక్ మేడం.
అవునండి, మారుస్తున్నారు సార్.
ఓకే మేడం.
Please note that the correct link of the feedback form has been shared in the link. Request all participants to fill it.
Now it's right.
Right. Thank you, sir. Thank you, sir, for addressing it.